Hello Pre-Calc kids, welcome back to another lesson in AP Precalculus. This is Mr. Bean, and today's lesson we're going to look at what are we looking at? Oh yeah, inverse functions. Inverse functions is what we're going to talk about today. So some of you have already had inverse functions in some of your classes, especially Algebra 2, but again, we're going to approach this like you haven't seen it before. And I do apologize, I think this video is probably going to be longer than most of my videos, just because it's a little bit intensive with some of the work that we have to do. All right, so let's get started. So a function f has an inverse function, or in other words, it is invertible. So we say a function's invertible if we can take the inverse function, if we can find the inverse function. Okay, now that only happens if every output value is mapped from a unique input, if every y value is mapped from a unique x value. That is a little confusing. Let me come back to that. Okay, I will come back and explain a quick and easy way to know if it's invertible or not. All right, the first thing I want to do though is we're going to write down some coordinate points of this thing. So let's see, what are some coordinate points here? I've got a -2, 3 for sure, right? It shifted left 2 and up 3. So there from the origin, left 2, up 3. So -2 and 3 is a y value. Let's just write a few more here. I've got a dot there. That would be -3, 2. And I'm not doing these in order. I don't care. I'm just filling in a table of some values. There's another coordinate point right there, -1, 4. And then we need one more here. Look for where the coordinates cross. Oh, it's off the grid. I didn't do that very well. It would be down here, -4 and -5. All right, so we have these coordinate points. Again, they're not in order. That doesn't matter with what we're doing. So the next part of this paragraph down here says that when you have an inverse, what it's really doing is reverse mapping the function. So the x and the y values get swapped out. If you have f of a equals b, then f inverse of b equals a. That's what this little -1 thing means. -1 is talking about the inverse function. Do not get that confused with, I'm going to write it real small here. You might put it off on your notes on the left. Don't get it confused with the reciprocal, right? X to the -1 is the reciprocal and becomes 1 over x. That is not the same thing as inverse. You can tell if the -1 is inverse when it's used with function notation. So if you have f of -1, f to the -1 of x, that is representing an inverse function, and it is not a reciprocal of 1 over the function f. So just be careful about that. It's all about context, knowing when you're talking about this. Okay, so let's go back down here then. If you have a coordinate pair AB, so when you have AB, then the inverse function will have the coordinate pair BA. The x and y just got traded places. So let's take this. I'm now going to switch up my colors here. Let's take this -2, 3 and swap them. This would become 3, -2. This becomes 2, -3, 4, -1, and then -5 and -4. So what I'd like you to do is take these coordinate points, and did I do it right? Yeah. Take these coordinate points, plot them on your graph, and see if you can sketch the connecting points of this, of what it would look like. Okay, so go ahead and pause your video now and try and do that. All right, here's what I came up with. It's not perfect, but it looks close. So you can see there, it kind of does look like this. It's just been turned a little bit differently. It's some type of weird reflection. We'll get to that in just a second. So, so that would be the inverse function. Now, here's a quick way of knowing if a function is invertible, and that is if the function is increasing or decreasing only. So if the graph's going up somehow and it's never turning around, or it's going down and it's never turning around and coming back up, then it is invertible. If the graph turns, so if I have something like a parabola, if it turns and has a max or a min, so that little minimum right there, that is no longer an invertible function because the output values, wait, I didn't say that right, because there are output values that are the same for different input values. Now, what that means is it would be failing the horizontal line test. So let me show you what I mean. Do you remember vertical line test? Vertical line test is tell if a graph is a function or not, where you just take a vertical line and you check and see, like, if it went like this and reversed back on itself, that graph would fail the vertical line test. If we did a vertical line straight down, it would fail it, right? So what we're going to do instead is the horizontal line test. So if we go back up here, I'm going to draw a vertical line. Okay, here I got my little vertical line here, and I'm going to go down and watch the black original function. Does it ever cross it twice? That horizontal line never crosses the original function 2 times. And since it doesn't, it passes the horizontal line test. Therefore, we can do the inverse. So if I took it to this here, so take this line, so see there how it crosses it more than once, that parabola, it would fail the horizontal line test. Therefore, it's not invertible. We'd have to do something to it first. So we will do that in this lesson. We're going to do something to those functions so that we can take the inverse. Okay, so let's check these. So are the following functions invertible? Do the horizontal line test. So for this one, if I just start sliding a horizontal line down, it never crosses the function 2 times. So that one's invertible. If we do it here, and the same thing here, that one's invertible. You will see on the practice, by the way, I've got 1 or 2, maybe on a corrective assignment, where it fails the horizontal line test and it's not invertible, but I'm still going to ask you to sketch the graph of the inverse. It's just for the practice of swapping your x's and y's and playing around with that, okay? So understand that sometimes the answer would be it's not invertible, but on the practice, you're still going to just sketch the graph of what the inverse would look like if we considered it a function. So now what we're doing here is we're going to be graphing the inverse of both of these. So to do that, let's just swap our x's and y's again. So I'm going to take a red marker here. So -3, +1. Swap those. So instead of -3, 1, it would become 1, -3. 1, -3, put a dot. So you want to identify a few points that you can do that with. So here's another one. This coordinate point, -1, 0, would become 0, -1. So swap the x's and y's. Here's a point here. That point is 1, -1. So then it would become -1, +1. And then that point right there is 2, -3. So swap the x and y. It would become -3, 2. All right. And now we try to sketch the graph. This is where it gets a little tricky. Let's see. It would be something like this. Okay, that's better. All right. So something like that is the graph. Now here's what we can do after we are done graphing. The good way to check it is that the inverse function is going to be a reflection off the identity line, y equals x, the identity function, y equals x. So if we were to graph y equals x, you should be able to see the reflection. So let me graph a line real quick. Okay, there's my y equals x line. So a slope of 1 goes through the origin. Now that line you should be able to visually see. Look at the black. The black line, if we reflect it across the y equals x line, you would get the red inverse function. The red one is the inverse. I'm going to even write that on there, that the red is the f inverse of x, just to show that. Okay, so you can see there, it's a little bit easier to see, yeah, it's reflecting across that line. Now, we could draw the line first and try and reflect it, but that's really hard to reflect across a diagonal line like that. So the easiest way is just take your x's and y's, swap them, then draw that line to see, did it work and does it look like it's a reflection? It's usually pretty quick to see, oh yeah, that didn't work if you did it wrong. Okay, so I'm going to have you pause the video and try and do that with this. So swap your x's and y's, draw your y equals x line, and see if you can get it to make the inverse function. All right, there's my g inverse graph. I drew the y equals x line just to get a feel for if it was if it looked like it was reflecting, and it does. It looks like it reflects right across that line. You can see here, it's just a mirror image across the y equals x line. That's kind of cool. That looks like a DNA helix or something like that. All right, so that is how we sketch the graphs. All right, now we're going to talk about domain and range for a little bit. So domain and range of a function. If you're going to, basically, it just swaps from the function to the inverse function, the domain and range swap. So if you are given an original function and it asks a question something like this, what is the minimum value? Well, that's asking the minimum value of f inverse, which is saying, what's the smallest y value of the inverse? You have to translate that to saying, what is the smallest x value of the original? So the smallest y value of the inverse is the smallest x value. So here's the smallest x value, the smallest x value of the original function. So the minimum value of this is -2, the minimum value of the inverse. So what's the maximum value of the inverse? Well, what's the highest y value of the inverse is the largest y value of the original function. X value, sorry, I keep saying the wrong thing. Largest x value of the original function, which is 3. So that one is 3. The maximum is 3 of the inverse. Okay, so domain and range get swapped, just like x's and y's get swapped. Now let's figure out how you get the equations of the inverse. This is the one we started with, the very first problem we did, where we had this graph of x plus 2 cubed plus 3. What we're going to do now is find the inverse equation, the function for it. One of the methods is just take the x and the y, swap them. swap the roles of x and y. So this is my y value. So I'm going to now say that it's x equals, and then it's, instead of an x, it's y plus 2 quantity cubed plus 3. So I switch the x and the y, and then you solve for y. So I'll subtract 3. Oh, this line right here, by the way, that line is to help me know not to go past it because I didn't give you a ton of room. So I'm trying to be nice to you and make sure that I do my work within the space I gave you. So subtract 3 from both sides. Y plus 2 quantity cubed. Take the cube root of both sides to get rid of that exponent of 3. So the cube root, that's x minus 3, equals y plus 2, and then you subtract 2 from both sides and we're done. So it's, instead of y equals, I'm going to say f inverse of x would equal, and then I have the cube root of x minus 3 minus 2 because I subtracted that 2. So this here is the inverse function of the original, from the very beginning. So this is the graph in red that I had on the first page. Let's go back to that. In fact, let's verify. If I shift a cubic function right 3, cube root, I should say, not cubic, cube root. If I shift it right 3 and down 2, does that work? From the origin, I shift right 3 down 2. Yes, it does. That's perfect. It's right there in the middle. So that matches up with my graph here. All right, now let's do one that's harder. Sometimes in order to find the inverse, to make the function invertible, we have to restrict the domain. Here's what I mean by that. So here we have a function that is quadratic, and the graph creates a parabola. Let's just sketch a quick little parabola over here. It's shifted up 2, so we're going to go 1, 2, like that, and then it's going to be a parabola that opens up like that. Say that fails the horizontal line test. We can't, it's not invertible, right? We talked about that. We can't take the inverse because it's failing the horizontal line test. So what we're going to do is, I want you to write this on your notes. We're going to find the inverse for this function for x values that are, now I can only take one side, the left side or the right side. I'm going to choose for x is less than or equal to 0. Now, on the problems you're given, this will already be a statement there for you. You're not having to guess what you do. The problem says find the inverse for, and it'll tell you which side. So I'm just, for this example, I'm going to write this out. For x is less than or equal to 0. So what we're focusing in on, let me draw this. We're only focusing in on this part of it in red. This half of it. This blue part we're not doing. When we're done, if we could take this whole thing, it would look like this. We would rotate it. This is what the inverse is going to look like. It would be looking like something like this. But what we're doing is we're only going to find this part of it. That's the part that's getting reflected that we're going to look at. Okay, I'm just doing this to show you. It's really helpful if you know what some of these graphs look like. It's not necessary to be able to do this without the graphs, or with the graphs, I should say. You don't have to be able to do it with the graphs, but it is helpful. So let's solve this thing. So this now becomes, this is your x equals 1/2 y squared plus 2. Subtract 2 from both sides. We get x minus 2 equals 1/2 y squared. Multiply everything by 2. We'll get 2x minus 4 equals y squared. How do we get rid of the squared? We have to take the square root. So this is where we're going to get, I'm going to write it over here, y equals plus or minus the square root of 2x minus 4. So this is the inverse, but there's two equations. We have plus or minus. Remember, when you take an even root, you have to do plus or minus. The reason there's a plus or minus is because the plus is the positive side and the minus is the negative side. And so what we actually want, the answer to this is that f inverse of x is the negative square root of 2x minus 4. It's the bottom half that we're looking at for this one. Okay. Now, what's the domain and range of the inverse function? Well, if you could look at the domain and range of the original, that helps you out. So the domain of the original was that all the x values had to be less than or equal to 0. The range of the original function was all the y values were greater than or equal to 2, because this plus 2 is shifted the parabola up, and so it's this here. So now we can say the domain is going to be all the x values that are, so it's swapped. It's this number, this 2 here, that are greater than or equal to 2. That matches my picture. All the x values that are larger than 2 for the inverse here. And then the range is going to be all the y values that are, so it swaps with this. All the y values that are less than or equal to 0 swaps with the domain of the original. So less than or equal to 0, and then that matches my picture here. Okay, so that's probably the hardest thing you'll have to do on this practice is when you have a restriction on a domain and then coming up with the correct equation, especially if there's a plus or minus, which one is it, and then getting the correct domain and range of the inverse function. So what we're going to do is practice a few of these. We're going to find the inverse of these and then identify what the domain and range is. I think sometimes it's easier to start off with the domain and range of the original. So if I write down the domain of this thing is, what's the square root graph look like? The square root graph, I'm just going to do it right here so you see it. The square root graph goes like that, and I'm shifted right 3 and up 2. So the domain is all the x values that are greater than or equal to 3. The range is all the y values that are greater than or equal to 2. Okay, that's going to help me quite a bit when I get down to the domain and range of this one. In fact, I can just do it right now. That means the domain has to be all the x values that are greater than or equal to 2, because it's swapping here, and the range has to be all the y values that are greater than or equal to 3, because it's swapping the domain and range. All right, let's do this. We get x equals square root of y minus 3 plus 2. This becomes x minus 2 equals square root of y minus 3. Square both sides. X minus 2 squared equals y minus 3. Add 3 to both sides and we're all done. So the f inverse is going to be this thing and then adding the 3. And then we're done. So that's a parabola, but we have a restriction on the parabola. We're only taking the right side of it, all the x values that are greater than 2. 2, 3 is where the vertex is. We can see that from the vertex form here. So it's only the right side of that graph. So of the parabola, we're just looking at that side of it. So now let's do another one. So what's the domain here? Let's identify real quick. The domain of this one is going to be all real numbers. It's kind of like this weird R I do. That's all real numbers except for, I'm going to say that x cannot equal -6. X can't be -6 because that would make this a 0. And if you remember from Mr. Brust's lessons when we did rational functions, we're going to have a horizontal asymptote at y equals 0, right? The degree on bottom is larger, so that y equals 0. So it's everything, all real numbers, except that y cannot equal 0. We'll have an asymptote for that. For rational functions, we know for this thing here, where it's not going to ever equal 0. You can't make the numerator be 0 if all there is a 3 here. All right, swap things and solve. X equals 3 over y plus 6. Multiply both sides by this denominator, y plus 6, and you get x times y plus 6 equals 3. Then distribute the x. Xy plus 6x equals 3. And then we're just trying to solve for y. So let's get rid of the 6x here. Subtract it to the other side. And then we get divide both sides by x. So when I do that, in fact, let me clean this up a little bit here. I'm going to show my step here. I'm going to divide every term by x. And when I do that, that makes this a little bit easier to see what's going on. Y equals 3 over x minus 6. Oh, instead of y, I should have put f inverse. Let's fix that. There we go. F inverse of x equals 3 over x minus 6. And then this works. I can't have x be a 0 here. So for my domain, it's all real numbers except for x cannot equal 0. And that works because here the range was y can't be 0. So here if the domain is x can't be -6, here it's y, not x, y cannot be -6. So it's all real numbers except for y cannot be -6. This one's a little bit more challenging. I'd say let's pause. Let's see if any of you can get this one on your own. This one is a bit more challenging, but there's some really good principles in this that you will use in AP Calculus. There's this thing called implicit differentiation, and you have to know how to do some algebra skills here that is involved here. So pause the video, try this one on your own, and then I'll show you the steps to do it if you couldn't do it, because it is a little bit more challenging. So I'm going to show you the steps that I've got so far. I find the domain and range for the original first, everything except -4, and then for the range, it's everything except 2. The horizontal asymptote would be y equals 2. Remember, the degree here is 1, 1. And so then I did my x and y's, I started solving them, switching things around, solve for y. But here I got a problem. I got too many y's going on. What you want to do is anything that has a y term, you get on the same side. So I get this 2y switches over here, subtract 2y, and anything that doesn't have a y term, so this, or y in it, so this term does not have a y, I'm going to bring it to the other side. So -3 minus 4x. Now that allows me to factor out a y from both terms on the left side. Once I factor out that y, now this becomes a lot nicer. My inverse function is going to be negative 3 minus 4x all over x minus 2. And then I can see here the domain cannot be a 2, so it's all real numbers, except that x cannot equal 2, and that fits perfectly with here. The range couldn't be a y equals 2, so that fits. And then here the range is everything except if I swap it, it would be a negative 4 there, so y cannot be a negative 4. And that does make sense because if you look here, horizontal asymptote will be a negative 4 because it's negative 4x over x, which is just going to be negative 4 for the horizontal asymptote. All right, so this one's really tricky. There's only one or two on the practice and maybe one on the corrective assignment somewhere there. But it's just to get you a little practice and stuff, some algebra skills that you'll use next year in calculus. Okay, the last thing, this one's pretty simple, and that is when you take f and f inverse, if you have a function and its inverse and you compose them together, what happens is if you plug in f inverse into f, you actually get the same thing as if you had plugged f into f inverse. They equal the same thing. And what is it that they equal? They equal x, the identity function. So that's how you can prove if two things are inverses of each other. That's what we're going to do. We're just going to prove real quick that these two things are inverses of each other, then the lesson's over. So what we'll start off with is f of g of x. That's what we're going to try and figure out. So we take f of x and we plug this whole g of x into that x right there. So it's going to be 2 over, so it becomes 2 over x minus 3 plus 3. So that 2 over x plus 3, 2 over x plus 3. And then we simplify what we can. So we get 2 over x. The minus 3 plus 3 cancels. Well, this is the same thing as saying we can, division with fractions, that's confusing. So let's multiply by the reciprocal, 2 times x over 2. 2's cancel, and you just get x. All right, so that worked. We just got x. Now that's only half of the work though. We now have to do the other way around, where you do g of f of x. So now when we plug that one in, we're going to take that whole thing, this function f, and plug it into that little x right there. Let me move that up because I didn't give myself enough room. All right, so this is going to equal 2 over something minus 3. So the something is this, 2 over x plus 3. 2 over x plus 3. All right, fraction and fraction, that's too confusing. So let's do 2 times the reciprocal, x plus 3 over 2 minus 3. Well, that's nice. The 2's are going to cancel. We get x plus 3 minus 3, and that just equals x. All right, so that's the proof. We just showed that these are inverses because when we plug them into each other, we get x for both instances. Whew, okay, we finished. You survived this long lesson. Sorry about that. I warned you it was going to be long. This is Mr. Bean signing off. Rock that mastery check, and this is the last lesson for Unit 2A, so rock that test as well, and I will see you back. I don't think I'm going to see you back until we get to Unit 4, for those of you who do Unit 4. Okay, we'll see you.